Hello everybody, I am Dr. Emre Süren. In this course, we are going to learn developing AI agents for pen testing from scratch. This is also a part of my bigger course, Offensive AI for Red Teamers. Previous course was prompt injection and jailbreaking. Now, as a continuation of this line of course, we are developing hacking agents. Now I would like to start with the setup of the laboratory. This is a hands-on course. Absolutely, time to time we will have some theoretical parts. So let's get started with the setup. First, we will use a desktop AI assistant. Some people call it MCP Client, but I don't want to call it in that way because I will call MCP Client for another purpose. We will start with a desktop AI assistant. Let me give an example. Claude desktop is one of the most common AI assistant in the market, but during our course we will use Fire. This client, we will see what we are not using Claude, instead we are using Fire. Second component, we will have an MCP server. Desktop AI assistant will connect to an MCP server. Basically, this MCP server implemented with Python code and stored on a server. This Python server will query an MCP client, which is running on a Kali operating system. We wanted to have MCP client as much as close to the Kali because our MCP client will trigger tools. So it is faster to keep a client closer to tools. MCP client is also developed with Python language. MCP client and MCP server is a GitHub project now, and we will download those components from GitHub. Then what we need a vulnerable website or vulnerable application to attack. In our case, we will attack a web page which contains a login functionality, and this functionality is vulnerable to easily guessing administrative credentials. Second, this application contains file upload feature which contains a vulnerability. Actually, the functionality is not checking file extensions in that way. It is possible to upload certain files as well, which will allow us to trigger a vulnerability on the cookie. Cookie is generated by using JWT token. This implementation, JWT token generation and verification logic contains a vulnerability. Actually, file upload feature will allow attacker to upload public key, private key, which is used to validate cookie. Unfortunately, cookie also contains a variable which holds the location of the public private key. In that way, attacker will create its own public private key and will try to generate a valid cookie. In that way, it will bypass all protections and grant system level access. This web application is not on GitHub yet, but after this course, I will upload. You can find this application on my GitHub account. One thing I forgot to mention about, to be honest, I haven't forgotten and I just wanted to keep it later. Desktop AI assistant connects to a large language model, right? Generally speaking, majority of assistants connect to OpenAI, but in our case, we would like to run a local model. Actually, that's why we couldn't use Claude. Instead, we needed to find an alternative desktop AI assistant, so we found Fire for these purposes. So let's get started setting up our environment. First, we need to download our desktop AI client. I'm using macOS. This tool works with three main operating systems, Linux, Windows, and Mac. I download the Mac version, then it is just next to setup. So I click it. Then I only need to move it to applications folder. When it comes to Windows, you need to double click and follow the graphical user interface. So let's run the interface. This is our Fire. Now, next, what we need to use large language models in order to run this model, we need to download Ollama. Here, the same way, I just download the package. The same way, I just drop on applications folder and it runs. Open Ollama. Ollama is the platform to run large language models. In order to install large language models, we need to execute some commands. Ollama run and model name. Let's see what model we in library page ollama.com library we can find the models. Ollama from Meta, DeepSeek, Ollama, Gemma, Mistral, and I would like to install Mistral model. In order to run this model, Ollama run Mistral. This is what I need. And it started to download. It is 4.4 gigabytes of data. Our installation is almost ready, 100%. Verifying. Who are you? Our first instruction, I'm a model. What model are you? Okay, it doesn't leak itself, but it says BERT. So we reminded BERT, which is one of the oldest model, right? We learned transformers, large language models with BERT. Actually, BERT was also from Google. It was a nice nostalgia. Okay, now we will run Ollama graphical user interface. Now we will query our models here, Mistral. Then I select it. What specific model are you? I was created by Mistral AI. Okay, cool. By the way, I also downloaded a couple of more models, DeepSeek, Gemma, Ollama, Qwen. So in that way, we will have opportunity to try all major models. We have also GPTOs, 20 billion here. Let's look at settings here to see if there are something interesting. So in your username, a hidden folder Ollama models, you can find the location of the files. Manifest and blobs are the two typical directories in models. Do you remember what is the third typical folder once we download open models? Yes, snapshots. Snapshot folder is used to manage two different versions of the same model. So it was good to see this. Cancel. Now close it. Now we are gonna connect our, then we don't need our terminal. Ollama runs, up and running. Then now we need to connect our desktop assistant, AI assistant, to our large language model. It's gonna connect through Ollama. Let's see what we have here. This is providers. In our case, we are running Ollama. Ollama automatically queried our models and listed here Mistral. This is the name of the Mistral, context window, and max token. These are quite relevant for us because during our exercises, we will use a lot of tokens. This is one of the reasons that I don't want to use an enterprise model. Instead, I want to run it on my computer. As we are experimenting right now, so it is better to run models which is relatively cheaper. Once you are done with the experiments and you just want to showcase, in that case you can use models from enterprises. But in this case, so you need to select the same model actually, because you studied with model Ollama, then you want to run it on, let's say, Gemini. Gemini is the paid version, enterprise version of the Google. You should use the same model once you are presenting your work. You can find models online. For example, Together AI provides open models. Anyway, here you will see 4 options. It is enabled. Tools. This means that if this model can connect to an MCP server, so if you would like, you will need to enable tools here. Unfortunately, I have seen several YouTube videos or education courses. People are using desktop assistants and especially this Fire. And whenever they try a model, it doesn't work with the tools, then they think that this model does not support tools. Actually, it supports. Unfortunately, Fire does not provide proper messages that you cannot easily understand that you didn't enable tools. By default, majority of times, these tools come disabled. That's why you need to select enable it. We don't have vision, we are not going to process images, videos, etc. That's why we are not selecting. And Mistral is not our default model. Whenever we start a new conversation, it starts with the default model, and I will select Gemma because it is my favorite model. Since last year, I get the best results from Gemma when compared to GPT, Qwen, DeepSeek, Ollama, and Mistral. And I don't know this model, it's a small model, I just wanted to try. So here I want to enable tools, Ollama, enable tools. Cool, this is our configuration. As I mentioned, I'm using Together AI. Unfortunately, this platform does not provide opportunity to access Together AI. Instead, I created an account from Google. Google pretty much provides cheapest models right now. That's why I'm using. In order to access your account, you need to write this URL, generative language Google APIs.com. Then you will write your API key. I don't want to click it right now. Here the models, supported models, you can find through this API, and we will see which model to use. And every model has different capabilities. That's why you cannot select randomly. When it comes to tools, now we want to connect our MCP server to our MCP client. But where is our MCP server? Let's download it. This is our VSCode. Now we will clone a Git repository from GitHub. And what was the name of the repository? MCP Client server. This name actually misleads a little bit because it contains both server and client, but the naming conversion is a bit of conflicting here. Kali server is the client which should be located on the Kali operating system. MCP server is the server which should connect to the desktop AI assistant. And you can see the served applications through this MCP server. You may find the use cases and usage of this MCP Client server and client in a CTF competition, and we will do more complex example during our exercises. And unfortunately, the source code of this exercise is not also available. That's why you can only watch it. As I mentioned, after the course, I'm going to release my code base through my account. This is my account. You can find the code base on my GitHub. Now let's grab the URL and go back to VS Code. Paste, open in a new window. This is our MCP Client server. As you see, this is the JSON file that we can use on our desktop AI assistant to connect to our application, our MCP server. Copy. Then go to our tools. We can click local. Then we can paste. I will show how we can do it. You should name your tool. Please never use this character because it is not compatible with LLM models while calling their services, unfortunately. And try to use underscore letter. You don't need to provide a description, but description is really good because AI assistants can learn from the description. Whenever we use a desktop AI assistant, we query MCP servers, and from MCP servers, we read their capabilities. So that's why it's a good practice to write here and command. And this is the command that we are going to run on our desktop AI assistant. And here is the code preview part. Let's copy this code and examine together here. So first I run the Python code under virtual environment. Once you set up this code base, you will create a virtual environment on your system. Ctrl+Shift+P. Python create environment. You will click this button .vnv and it will be created under your folder. So it will isolate this code from your computer. And this is the Python. Second, we need to show the MCP server. As you will remember, we will run MCP server on our AI assistant. Then we will provide the IP address of our MCP client where Kali server. In other words, MCP client is running. MCP client will run on that port. So we just provide this information, then our AI assistant will run this code. And here is our ID. This is Kali Web, comes from here. We didn't provide a description and it's a local MCP server. This is the address of the command. So we will run Python. We will trigger this argument, MCP server. And this is the other arguments which shows the MCP client to connect. So that's all. Currently, as you see, it is red because MCP client is not running. Now we need to set up our MCP client on our Kali. First, I need to run my VMware, then run Kali. I need to download MCP Kali server to my computer. As you will see, Kali server Python and MCP server Python is here. So this is the code that I need to run. Python 3 Kali server IP address. So we are running our Kali MCP client on this IP address. So we are coming back here, then controlling our tools, Kali web. Let's close it. Let's run it. Now it connects. Kali web contains tools, resources, and prompts. So what is next? The next is the application to run to attack. But before running this exercise, I would like to start a new chat. and try to run at least one nmap command. Here we selected Google. We can also select Ollama. We can select Gemma, let's say. So ping google.com. I only provided this information. Here what we have prompts, saved prompts. We have saved prompts. We have knowledge base. This is maximum tokens. 16,000. Here it is quite essential to set the highest number because during a penetration testing we will consume a lot of tokens. You will see sometimes 1 million token we will consume. So if we keep this number higher, then we will let our model have a higher context window. It can remember that much most recent conversation tokens actually. That's why it is quite important. Here we are providing temperature 0.9, which is the default value, because we want our model to be creative right now. But in the course of time, we may try to reduce it 0.1, 0.2 to get more deterministic answers. Ping Google. I provided ping Google. It says registry Ollama AI library Gemma 3 latest does not support tools. Let's go to workspace providers. Ollama Gemma. Gemma has tools reportedly here. It is enabled. This does not mean that it's gonna run. We can also check this on the web page of Ollama Gemma 3. As you can see, Vision and Cloud. There is no tools here. Okay, let's see. Ollama provides tools, DeepSeek. Gemma, no tools here. As you see, Mistral, yes. So as you see, Gemma does not provide tools. That's why we need to switch our model to the next one, GPT also. Let's say ping. You can click this refresh button to do the same command. Now we are here on our Kali to see if we get ping command here. It ended without response. Coming here again, it ended. So let's see if GPT-OS is enabled. Providers, Ollama, GPT-OS tools is enabled here. Let's see GPT-OS if it contains tools. Yes, it contains tools, but as you see, our AI desktop agent cannot access to our client. Let's close this one. Coming to that point again, it didn't run. Now I'm gonna use Qwen. What I know about Qwen, once we write ping google.com, it will generate some artificial response instead of asking to the tool. Let's see. No connection. Now, yes, this is our ID. Actually, it accessed the execute command endpoint. Yes, executing ping google.com. As you see, our model Qwen 3 coder latest managed to access trigger our tool. As you can see, I haven't provided anything to the conversation, only ping google.com. It automatically identified there is a tools in the environment, MCP server. From MCP server, discovered the execute command method and tried to use this method. Unfortunately, it is not gonna finish. Why? Okay, hopefully. Ping google.com and error calling tool execute command MCP error request timed out tool call error. Let's see on the tools Kali browse. And from here we can see the methods provided on the MCP server. Cool. Then coming back here, in this case, I will give this command. We didn't see the command yet. It found execute command. Normally what we are expecting, ping. Yes, this answer. All right, stop generating. We couldn't manage to ping Google properly. We are selecting DeepSeek now. Run the same command. Registry does not support tools, but here, DeepSeek, it contains tools, but in our case, our DeepSeek R1 cannot. Interesting. Let's try it again. Try it again. Here, as you see, providers, tools enabled. Anyway, come back. DeepSeek Ollama guard does not support tools. Ollama 3.1 tools. Ollama guard we have. Ollama guard actually does not contain this feature. Yes, it's right. Mistral. Let's go back here. Mistral able to send this command, probably. Okay, quite good. So most promising answer comes from Qwen and Mistral, but we couldn't achieve success actually. We will see how we can manage this in the next lecture. For now, we are done. I am Dr. Emre Süren.